Hey guys, it's Chihiro. Welcome back to another 5 Academy video. Today we're going to be going through an ACT math mock practice exam. 60 minutes and 60 questions that we're going to be going through here, fully breaking down all the problems and showing you the solution methods that you can use to solve them, oftentimes showing multiple methods instead of just one. So you can learn as much as possible. So the point of this video is not just to show you an exam and what it looks like, but actually give you an idea of what type of solution methods and skills you can use to succeed on the test. And that way, if you want to actually, for example, take this test or take other practice exams, you can use this as reference information because problem types repeat from exam to exam. So if you are familiar with at least, one or two or 5 or 8 practice exams worth of problems and kind of how those problems should be answered, you'll slowly develop, those skills across all of those problems and all of those skills that, like I said, tend to repeat from the exam. So what I'm going to do is go ahead and get started. What I would also recommend is, if you can and if you have the time, which if you're studying for the ACT, I hope you do, is go ahead and download the PDF for this exam and take the exam, the entire thing yourself, and see how you do. There's an answer key at the back, very bottom of this PDF, and you can grade your test to see what score you get out of 36. And then you can watch this video for the exam after to compare your answering methods against what I do in this video and see if there's anything that you could have done better, anything that maybe I could have done better that you did really well, and if there's any skills you don't understand, most importantly, you can use this video as a way to learn them for the problems you got wrong especially. So without further ado, I'm going to get started. This is probably going to be a long one, and I'm probably going to be taking a little longer than just 60 minutes because I want to break down all the problems for you guys here. So let's get started. To keep up with rising expenses, a fish store manager needs to raise the $2.75 price of guppies by this much. What will be the new price? Whenever you're increasing or decreasing a number by a certain percent, this is the formula. It's the original number multiplied by the percent written as a decimal. Multiplied by 1 plus or minus the percent written as a decimal, okay? So in this case, this number is going to be 2.75. This is just going to be 1, so don't need to change that. And then the percent is what? So 36% written as a decimal is going to be, what you do is you take the number, 36.0%, and you just move the decimal 2 places to the left. So you end up with 0.36, okay? So 2.75 times 1 plus 0.36 is equal to, let me just do it really quick on my calculator, 3.74. Let me see, that's answer option B, okay? So you can see it's really just the same thing as 2.75 times 1.36, which just happens to be 1 point, whatever that percent increase is. If it was a percent decrease, this would be a minus, okay? So if it's a percent increase, it's a plus. So again, plus here because it was increased, but if it was decreased, it would be a minus. If 4x minus 8 is this, then what's 2x plus 1? 4x minus 8 equals 30. Let's add 8 on both sides. 4x equals 38. Divide by 4 on both sides. Do that on my calculator. 9.5. Now x is not, 9.5 is not your answer. We have to plug it into this. 2 times 9.5 equals plus 1 equals 2 times 9.5. If you do it on your calculator, you get 19 plus 1 is equal to 20. As a salesperson, your commission is directly proportional to the dollar amount of sales you make. If your sales are this, your commission is this. How much commission would you earn if you had 2,200 in sales? So when it says something is directly proportional to something else, that means that the ratio of those two things is always going to be the same. So for example, if I give you a recipe and I say 1 cup flour, 2 cups milk. And then let's say you want to increase the quantity because you have a lot of guests coming and you want to up that to 4 cups flour. You notice that I went times 4 here, so I have to also go times 4 here on the other parts of the recipe. So that gives you 8 cups milk. Same principle here, okay? The ratio of 1 to 4 is the same thing as 2 to 8, or 1 to 2 is the same thing as 4 to 8, right? It's a ratio of half. So what I'm going to do is apply that same kind of logic to this problem. So it says let's do the ratio of sales to commissions. Okay, that ratio is going to be, in the first case, 650 sales to 97.5 commissions. That's going to also equal, let's make that. So we had 2,200 in sales. And what's my commission? How much commission? That's the question, right? So we want to identify that. Let's call that X. So now what I have is I have an equation right here that where I only have one unknown, and I can solve it. So what you can do is cross multiply and divide. 650. So let's multiply 650 by X is equal to 2,200 times 97.5. That gives you 214,500. Divide both sides by 650 to isolate the X. You end up getting 330. So you'd end up having $330 in commissions. You could also solve it by multiplying both sides by X. You end up getting 2,200 equals X times whatever that ratio is. And then you could, find the decimal equivalent and divide that across both sides. Okay, you'd get the same answer. All right. Number 4, in any parallelogram ABCD, it is always true that the measures of ABC and CDA are what? Okay, so it says in any parallelogram. So let's just draw a parallelogram. If you know what a parallelogram is, it's really any four-sided shape where, for example, like a rectangle where these two sides, the opposite sides are parallel to each other. So these are parallel and they're the same length. These are parallel and they're the same length. So for example, a square would also be a parallelogram. A rectangle, any rectangle is a parallelogram. A rhombus, a parallelogram, like, well, this is actually just a rhombus, I guess. But you see if I drew it correctly, your opposite sides are the same length, and they happen to be parallel to each other. They go on forever and they don't intersect. Okay. A trapezoid would not be a parallelogram. That's the example of a four-sided shape that's not a parallelogram, or a kite. Okay. So the measures, so let's just label it A, B, C, D. Right, we're going to go all the way around. So it's saying the angle measures of ABC, it's that one, and CDA are always what? Well, in this case, they both add up to 180, and they're equal. They don't have to be less than 90. So what you're going to realize is for a rectangle, specifically multiple answer options will be correct. But for a parallelogram, like I had drawn earlier, I'll draw another one. That's not a parallelogram. Okay, sorry. This is not functioning as expected. There we go. Okay, so A, B, C, D. So it says ABC and CDA. We notice what? They're clearly the same because these two sides are the same, these two sides are the same. That means the opposite angles are also going to be the same. Okay, so they're going to be equal. Now, they don't have to be complementary because these two are not complementary. Complementary means they add up to 90. So really, A and C are the same and they're both wrong. Supplementary means they add up to 180. In the case of a rectangle, they do add up to 180. In the case of a square, also, they will. But that's not true for every parallelogram or rhombus. Okay, so that's going to be wrong. And they're each less than 90. In this case, they are both less than 90, but they don't have to be less than 90. For example, if I had just drawn the parallelogram like this, and I said this is B and this is D, then these are both greater than 90. Okay, so it's all about how you draw it and label it. But the opposite angles are either both going to be greater than 90 or they're both going to be less than 90. They don't have to be either one of those. They can be either of those two options. The product of this is equal to what? Okay, so what we're going to do is combine like terms. So we have constants, we have an x term, and then we have a y term. Take it one piece at a time. So your constant is going to be 4 times 2 equals 8. So any answer option that doesn't have 8 at the beginning is wrong. Then you're going to have x to the third times x to the fourth. This is not going to equal x to the 12th. If you see x to the 12th, it's wrong. So what you're going to do here, when you have two terms like x to the third times x to the fourth, and they have the same base of x, you add the exponents together. X to the 7th. Okay? Right off the bat, 8x to the 7th, you're going to end up with Answer option D. Let's just do the last part. Y to the second times y to the third does not equal y to the sixth. That's wrong. Really what it is y to the second times y to the third is equal to y to the 2 plus 3, which is equal to y to the fifth. Okay? So what you do is you take all your terms, 8x to the 7th, y to the 5th, and you combine them. Because these are all being multiplied, we just broke it out bit by bit so that we can digest the problem piece by piece, make it a little easier. If 0 is less than x is less than 1, then which of the following has the greatest value? Let's just take a number, for example, 0.5 is equal to x. So square root of 0.5, you can evaluate all of these. The greatest value is going to end up being, and let me just plug all these into my calculator and write all these out. So greatest value, the square root of 0.5 is going to be 0.7. Square root of 3 times 1.5, 3 times 0.5 is going to be 1.5 to the half. It's going to be 1.22. Square root of x to the squared is going to be 0.5. 0.5 times 0.5 to the half, that's going to be really just half of this, so 0.35, which is the same thing as 0.5 to the 1.5. Yeah. And then 0.5 to the 0.5 squared is going to be 0.25. Your answer is clearly B. So just plug and chug for problems like that. If in the isosceles right triangle below, AB is equal to 11 inches, what is the length in inches of AC? Okay, isosceles right triangle, what does that mean? So first of all, right means one angle is going to be 90 degrees. So it's a right triangle. You can use hypotenuse. You can use Pythagorean theorem, and you can use sine, cosine, tangent ratios to solve this. So those are the tools that you can use. Now, they add in the isosceles bit to make it even easier. If you remember what an isosceles triangle is, it's where you have two side lengths that are equal to each other. So usually isosceles triangles, they'll give you, you'd think it looks like this, where these two are equal, right? This is equal to this, and you have a short one. But you can have a version of that that's actually a right triangle, which is what you have here. So you'd think, okay, which two sides are going to be equal to each other? It looks like these two are, and they actually are. The way you verify that is, you know that the hypotenuse is always opposite of the 90-degree angle. It's the largest side always in a right triangle. And it can never have another side that's the same length as it, because in a triangle, the sides and their dimensions are based on how big is the angle that's opening up to that, that's opposite of that side. So this side has the largest angle, right? Because this is 90 degrees. These two are not 90 degrees. They're less than 90. So that means that you only have one side that's going to be the largest. On the opposite, these two angles are going to be the same, and that's why they have opposite sides that are the same in length. Okay? So that means that these two sides have to be the same. It's asking for what is the length in inches of AC. You can either do a Pythagorean theorem, 11 squared plus 11 squared is equal to, we'll call this C squared, and you end up with square root of 242. Okay? Right, if you do 121 plus 121 equals C squared, 242 is equal to C squared, and you do the square root of both sides. Okay? You can also just remember that isosceles right triangles, if you have x squared of 2, this is how these are always going to be, these ratios always exist. So your answer is really 11 squared of 2. Now, you'd think, how does that match this? It does match because 11 squared of 2 is the same thing as saying 11 times, so you could rewrite 11 as square root of 121 times square root of 2, and that turns into square root of 121 times 2. That turns into square root of 242, okay? Because if you rewrite it as a radical, you can move the 11 essentially back into the radical, with the 11 just being rewritten as square root of 121, which it is square root of 121, okay? This is just some exponent rules that you can use to your advantage. And oftentimes problems will have you simplify the radicals it's more common for you to see the 11 squared of 2 answer option in the answers rather than the larger version with the larger number of 242. In a bag of 200 Skittles, 30% of the Skittles are green in color. If you randomly pick a Skittle from the bag, what is the probability that the Skittle picked is not one of the green Skittles? Okay, so probability of any event is going to be equal to the number of desired outcomes divided by the number of total outcomes. Okay, so probability of not green, right? That's what we're looking for. Is going to be how many not green are there? So in a bag of 220 Skittles, 30% are green. That means that 70% are not green. So let's just write, I mean, we don't even need to use this fraction because we know it's going to be 70%. It's going to be equal to 1 minus the probability of green. Right, so 1 minus 0.30 is equal to 0.70. This formula would be what you could use if you really wanted to calculate it out. So you could say probability of green, you could say is 220 times 0.3, which is equal to, I'm going to do it on my calculator, 66. Okay, so probability of not green is equal to 220 times 0.7. 0.7 times 220 on my calculator is 154. Then you could say, or sorry, this is not probability, this is number of green. If we're just trying to find numbers, and you can plug that into the formula up here, right? You could divide 154 by 220 and then simplify it if you really wanted to. That's kind of what I'm showing you there. Now, I'm not going to do it that way because that's really not the simplest way. Simplest way is to just say, okay, 70% is what, as I know, that's the probability. And that's what that is. You could go through each of the answer options and identify what's the decimal equivalent of each. Just plug them all into your calculator, and you'll find that D is the only right answer. What is the least common denominator of these fractions? The best way to solve this is to just identify your denominators, and then go through all the answer options and see which of them is divisible by all three. Okay? 27 is not divisible by 15, but it's not divisible by any of these, actually. 75 is not divisible by 7, if I'm not mistaken, which is correct. So you could just do 75 divided by 7 on your calculator. You'll find that it's a decimal. So that doesn't work. 105, I think, is the answer. I think it's divisible definitely by 5, and it is divisible by 15. Okay? So it's the smallest number, the least number that is divisible by all three. Okay? That's effectively how you solve these problems without going through and so another way to do it is to just take all the denominators and multiply them by each other, but that'll give you a common denominator. It's not going to give you the least common denominator. If you want to actually find the least common denominator, do it the proper way. You do the factor tree of each one of them. You do the prime factorization. So this is 5 times 3. 5 is just 5, and 7 is 7. Okay. So what you do is once you have your prime factorization of all of these, you take, if I remember correctly, you just cancel out any repeats, and you end up with 5 times 3 times 7. End up with 105. If I did that correctly, that should be the right procedure. It's something along these lines. We have a more in-depth breakdown of this in our course videos in our website. They're not free, but if you wanted to check that out, we have a resource there that shows you how to do this. But the whole point is you're just trying to find out. You just essentially just. I'm trying to show you 2 different ways to do this. The best way, again, is just conceptualize what least common denominator is. Understand what it is, really. You're finding a number that's bigger than all these, but that's the smallest version that these all essentially fit into as a factor. Given 3x minus 4 is equal to 8, what is the perimeter of the rectangle below? Let's solve for x. So add 4 on both sides to isolate x. 3x equals 12. Divide by 3 on both sides, you end up with x equals 4. Okay? That means this is going to be 3 times 4, which is 3 times 4, and this is going to be 4. So you end up with 12 plus 12 plus 4 plus 4 is equal to 24 plus 8 is equal to 32. Perimeter is just, again, the distance around a rectangle. All right, solving an absolute value expression. Let's start with simplifying each of the terms that are the innermost terms and then move out from there. So absolute value of 4 times negative 2. What is this? Negative 8. 5 times 3 is 15. Okay, so absolute value of negative 8 plus 15. This gives you 7, right? Absolute value of 15 minus 8, effectively. You can rewrite it. Absolute value of 7 is just 7. Okay. So remember, even if while you're still inside of the absolute value, you can still have negatives. So you can have absolute value of a negative number. This doesn't, like, negative 5 plus 4, for example, this doesn't turn into absolute value of 5 plus 4. You don't take out the negative until you have a simplified expression like this. And in this case, the simplified expression doesn't have a negative, but you don't do what I just did here. This is wrong, okay? So you preserve that negative, evaluate everything inside the absolute value, and then at the very end, if you still have a negative left, you take it out. What polynomial is added to this so that the sum is this? Okay, let's rewrite that problem in mathematical terms. So we have a polynomial, and then we add something to it, and we end up with 4x squared minus x minus 6. Okay? So in order to find that something, I could just subtract x squared plus 4x minus 8 from both sides. Right? So this would cancel out, and this effectively gives me, hey, here's the unknown polynomial. It's just equal to this guy. Okay? Now, in order to evaluate this, you have to distribute the negative to each of these terms, which can get a little confusing with, you don't want to make sign mistakes. So what I'm going to do is rewrite this as 4x squared minus x minus 6 plus, and then let's just do minus x squared minus 4x plus 8. You see what I did? I distributed the negative to each of these terms, basically flipping the sign of each one. And now what I have to do is just add going down. Okay, now I just have to find the sum going down. I don't have to figure out any, okay, it's 4x minus x squared, negative x minus 4x. Like, it gets confusing if you do that. Negative 6 minus negative 8, I'm not going to make you do that. It's just way too complicated. So let's just do the sum going down, okay? So 4x squared negative x squared, 3x squared. Okay, so immediately we can cancel out answer options. Negative x, negative 4x, negative 5x. That's out. Negative 6 plus 8 plus 2. Okay, simple as that. What is the slope of a line parallel to this line in the standard coordinate plane? In order to find slope, we need to be in this form. Okay, you need to isolate your y value, and you need to make sure you have an x value that has a constant, or sorry, a constant next to it. That m value is going to represent your slope. Now remember, two parallel lines will have the same slope. So you just need to identify what the slope of this is, and any line that also has that slope is going to be parallel. Okay, so negative 3x plus 2y is equal to 5. Let's write it as 2y minus 3x is equal to 5. It's really the same. It's the same exact thing, but it makes it a little easier to see that now we're going to isolate y. Sorry, that's a 3x. 2y is equal to, these cancel, 3x plus 5. Your slope is not 3, okay, because we didn't fully isolate y. It's still 2y. We need to divide everything by 2. Or you could think of it as we're dividing everything by 2 by doing this, right? So y is now equal to 3 over 2x plus 5 over 2. Right? If I was to write it this way, it's really the same thing. These two cancel. You end up with 3 over 2x, or 3x over 2, same thing, plus 5 over 2. Okay, so this is your line. Any line parallel to this has to have a slope of what? M equals 3 over 2, per the y equals mx plus b form. If y equals x to the 3 over 4, then which of the following expressions is equal to y to the 4 over 3? Okay, so y equals x to the 3 over 4, and we want to find what's y to the 4 over 3. just do that to the 4 over 3 and do that to the 4 over 3. Okay, so y to the 4 over 3 is equal to what? So you have an exponent here raised to another exponent. You might remember that if one of the exponent rules is a to the b all to the c is equal to the a to the b times c. Okay, so it's going to be x to the 3 over 4 times 4 over 3, which is equal to x to the 1. If you do these two, if you multiply a fraction by its reciprocal, you end up getting 1. So like 7 over 12 times 12 over 7 is equal to 1. Because these cancel out, you just end up with 1. Think of it. It's going to be 7 over 7. Or sorry, that fraction evaluates to 12 over 12, right? 12 divided by 12 has to be 1. Okay, so you end up with x. For the function g of x equals this, what is the value of g of negative 2? G of negative 2 is just going to be where we plug in negative 2 across the entire x values in the function. So negative 2 all to the third minus 8 times negative 2. So negative 2 times negative 2 times negative 2. If you really want to make it simple and not make a mistake in the signs, minus 8 times negative 2 so yeah, this guy right here, if you can even do it on your calculator, and you'll end up getting negative 8, and then here you'll get minus negative 16. This ends up being negative 8. If you have two negatives next to each other, it turns into a plus 16. You end up getting 8. 16 minus 8 is 8. The perimeter of an isosceles triangle is 96 and the base is 26. What is the area of the triangle to the nearest square inch? Okay. Isosceles triangle. We talked about isosceles triangle earlier. So you have, let's just say, two side lengths that are the same. It looks like, let's just say it looks like this. I mean, it could look a number of different ways. It could look like, a really flat isosceles triangle where these two side lengths are the same. It's still isosceles. Or it could be a right isosceles, but it doesn't matter, right? So perimeter is 96. Base is 26. Okay, 26 right here. What is the area of the triangle to the nearest square inch? Well, what we know is if this side is x, this side is x, and we know that x plus 26 has to equal 96. So I can solve for x. Subtract 26 on both sides. 2x is equal to 70. That means x has to equal 35. Okay? So we just evaluated. Now we know we've fully defined this triangle. It's asking what's the area of the triangle to the nearest inch. So how do you find area of an isosceles triangle like this? What I would do is I would divide it in half. So now you get two right triangles. And you can find the area of just one of these. And then multiply it by 2. Because the area of one of these is just going to be this base times this height times half, right? Area of a triangle is equal to half base times height. Now, you might be thinking, why can't I just apply that to the blue triangle that I started with? Well, you don't know the height. You know the base, but you don't know the height. How do you find the height? The height is going to be this value. The height is not this value. This is not the height. You need to find the height. The height is exactly from top to bottom. The base is exactly from left to right. They have to be perpendicular to each other. Okay, so in order to find the height, I'm going to take this triangle right here, and let's just bring that out, separate it from the rest of this so it doesn't get too confusing. Let's try it like that. There we go. So what's my base and my height of this going to be? Well, the height between these two is going to be the same. Let me just extend that to make it clear. Okay, so they're going to have the same height. The base of this one's going to be equal to half the base of this one because I cut the triangle straight in half. And then this 35 here is still there. So what I can do now is I can use Pythagorean theorem, or I can use I'd probably just use Pythagorean theorem to identify h. So if you remember, a squared plus b squared is equal to c squared, where this is the hypotenuse. I know the hypotenuse is 35, so I could say, let's get rid of this. This turns into h squared plus b squared is equal to 35 squared. h squared plus 13 squared is equal to 35 squared. H squared is equal to 35 squared minus 13 squared. H squared, h is equal to square root of 35 squared minus 13 squared. Now you can evaluate all that, 35 to the second minus 13 to the second, all to the half. Ends up giving you 32.496, okay? Now, that's not your answer. Your answer is what's the area. So I need to now find the area of, knowing this here, right? H equals 32.496. I know this value. I know the base. Now I can do area equals half base times height, which is going to be times 26 times 0.5 is equal to 422. Okay? So half times 26 times 32 is equal to 422. The total cost of renting a car is 52 for each day the car is rented plus 34 cents for each mile the car is driven. What is the total cost of renting the car for 8 days and driving 490 miles? So let's just say cost is equal to 52 times number of days plus 0.34 times miles. Okay? This is a really easy way to just give the problem variables and just plug and chug numbers to solve it. So now it's going to ask what's the total cost. We're going to still evaluate cost. For renting the car for 8 days, 52 times 8 days plus 490 miles times 0.3 times plus 0.34 times 490 miles, right? This is going to give you your answer. 52 times 8 plus 0.34 times 490. 582.6. So this is all about just setting up a good equation. You can just use your rate. So you know you have a rate here, multiply by the number of days. You have another rate here, multiply by the number of miles. And then add that together. That's your cost. So it's just taking a word problem like this and moving it to actual numbers to define it is really what's tested. So the ratio of lengths of corresponding sides of two similar right triangles is 5 to 8. If the hypotenuse of the smaller triangle is 2 inches long, how many inches longer is the hypotenuse of the larger triangle? So it says two similar right triangles. So we're going to have, what does that mean? Two right triangles that are similar is effectively going to be two right triangles that look the exact same, but one of them is just a scaled up version of the other. Okay, so they have the same angle measures. Side lengths don't match, but they have the same angle measures. And it says the ratio of the lengths is 5 to 8. So if this length was 5, this would be 8. Okay? If this was 10, this would be 16. If this was 15, this would be, what's 15 times 8 over 5? It's 24, okay? Just an example. So now it's saying, now what does that mean, right? So like whatever side length is here, if you know a side length on the left one, you just multiply that by this ratio, and you're gonna get that slightly larger side length on the other larger triangle. So it says the hypotenuse on the smaller one is 2 inches long. Okay. And it was easier when I knew that it was 5. I mean, this is going to be 8, but how do I use this ratio of 5 to 8 to actually get my hypotenuse on the larger triangle? What you do is you multiply 2 times 8 over 5, because if you're going from smaller to larger triangle, you're going to multiply by larger number divided by smaller number. But if I knew this was 10 and I was trying to figure out what's that same corresponding side length on the smaller triangle, I would do 10 times smaller number divided by a larger. This would end up giving me 10 times 5 over 8. Okay, and then I would get a slightly different answer. But here, again, I'm looking at the hypotenuse of this one. I'm trying to find the same side length on the larger one. So I'm going to multiply by this ratio, not 5 over 8, but 8 over 5. 2 times 8 over 5 is going to be 16 over 5, which is 3.2. I believe so. Yep, so x equals 3.2. All right. To increase the mean of 5 numbers by 8, by how much would the sum of the 5 numbers have to increase? Okay, So what we're going to do is we're going to, so remember your average formula? So if you remember, the average formula is equal to sum of the numbers divided by the number of numbers, okay? So what we're going to do is we know, what do we know from this equation? We know that the number of numbers is 5. The average, the original average that we have, we don't know it, but we want to find, I'm going to call this average 1, average 2. Average 1 is equal to just average 1, average 2 is equal to average 1 plus 8, right? That's what this is saying. We're trying to increase average 1 by 8. Okay. By how much would the sum of the 5 numbers have to increase? And I also know I'm trying to just increase the sum by a certain sum of numbers. So what I can do is, let's plug this in. And I'm going to show you 2 different ways to solve this. Okay. If you just go ahead and plug this in here, you should end up getting average 2 is equal to, is equal to, so instead of plugging in average 1, I'm just going to plug in sum over 5. Sum over 5 plus 8. Okay. And then what I'm going to do is, so this just shows me, okay, the formula for average 2. It's just the original sum over 5, but I'm going to add 8 to it. Now, what if I move this 8 into this fraction, it'll actually tell me how much I need to increase the sum by. So let's do that. Average 2 is equal to sum over 5 plus, I want to move this into the sum fraction. This 8, I want to move that in. So I have to rewrite it with a denominator of 5. So I can do 8 times 5 over 5. This equals sum over 5 plus 40 over 5. Sorry, that's not equal. That's a plus. That's equal to sum plus 40 over 5. So I need to add 40 in order to get from average 1 to average 2. Again, this is all equal to average 2. Okay, that'll increase my average by 8 if I add 40. Which makes sense. Now, what's another way to think of this if that was a little too much? Let's erase all of this. Let's just, the other option is just assign values. So let's say your original set of values is 0, 0, 0, 0, and 0, okay? And we want to increase the mean. So what's the average of this? Average is obviously equal to 0, right? Okay, cool. Now you want to increase the average of the numbers by 8 to average 1, average 2. Average 2 is going to be 8, so you could just move all the numbers to be 8. And you see the sum is 40. Sum 2 is 40, sum 1 is 0. Okay? So with average problems, when you're asked to manipulate an average, you could just set everything to be 0 for the original case, and then move it all to whatever desired number you have, and it becomes very easy. What is the maximum number of distinct diagonals that can be drawn in the pentagon below? Okay, so because we're given a pentagon drawn out for us, we could probably just scribble all over it and identify the answer. Let's just do it. So if I'm starting at this point right here, I can do 1, 2. This point right here, 1, 2. This point right here, I already have 1, but I can do 1 there. So far I'm at what? Let's count. 2, 3, 4, 5. If I go to this point, I can't add here because I already have 1. I can't add here because I already have 1. So I'm kind of stuck. That's it. You're at 5. And you see I drew a perfect star. So that's how you know you've done all of them. Now you might think, okay, what if I can't tell if the problem is telling me to also include these diagonals here, like 1, 2, 3, 4, and then 1, 2, 3. That's at 7. Now we're at 8, 9, 10. It's not even an answer option past 8, so you know you're not including those. If 3x squared plus 14x equals 24, what are the possible values of x? Okay, the way you're going to do this is solve a quadratic equation. So let's first move the 24 over here. 3x squared plus 14x. You're going to subtract 24 on both sides. minus 24 is equal to 0. Okay, so there's two ways to do this. You can use quadratic formula. Actually, three ways. Quadratic formula, QF I'll call it. You can do complete the square, which is what I'm going to show you how to do. It's the hardest one probably. Sorry, not complete square. Box method. Which is really just factoring, but it's a little more complicated because you have a 3 up here instead of just a 1. And then the other method is just graphing. So you can just plug this into your graphing calculator and find what are the x-intercepts. Where are the points? Where are the y value? What are the x values when y is equal to 0? Okay? Let's do this one. So what you're going to do is you're going to draw a box with 4 squares in it. And you're going to first move it down here because it's a little too close to the rest of this. And you're going to put 3x squared here, and you're going to put your last term here, okay? And you're going to say, okay, I'm going to multiply 3 by negative 24, and I'm going to get negative 72. So what are two factors of negative 72 that give me positive 14? That's the question. Factors of negative 72 that give you positive 14. Okay, so I'm just thinking 18 times 4. Really, negative 18. Oh, sorry. 18 times negative 4 is going to give you negative 17, and they add up to 14. You could find this out by listing all the factors. So you get like 1 times 72, 2 times 36, 3 times 24, 4 times 18. That's where I ended up here. Okay, but there's more. There's like 6 times 12. There's 8 times 9. That's all of them. I just did all of them. Okay, so now what you're going to do is you're going to take each of these and put an x in front of it. And then you're going to plug them into the other two boxes. It doesn't matter which one you put them in. And then the last thing you're going to identify is you're going to get a value in each of these circles. Okay, each of these circles is going to have a value. And it's going to be the greatest common factor of each row or column. Okay, so for this row, what's your greatest common factor? They both have negative 4 in them, so it's going to be negative 4. And remember, this, you have to keep in mind the sign of this one is going to equal the sign of whatever is out here. So, for example, here you have a positive value, but you have a negative value here. The sign of this one's going to be positive because that's the sign of the closest box. Okay, so same thing here, 3x squared and 18x, they both have a 3x component. You can port x's over as well, you're supposed to. This is just going to be x positive, this is going to be 6. Okay, so your answer is going to be 3x minus 4, x plus 6 is equal to 0. That's effectively what you do here. You just take those and you put them into these statements. And now possible values of x, right? We're going to evaluate this. 3x minus 4 equals 0. You end up getting 4 over 3. X plus 6 equals 0. X equals negative 6. Okay. A swimming pool in the figure below has a divider represented by AD. The pool is an equilateral hexagon in this shape. Joey can swim the distance of AB in 30 seconds. 30 seconds. Okay. If Joey can swim from point E to F at a rate of 100 meters per minute. Okay. What is the distance from point E to F in meters? Okay, so we're given 2 units. We're given 2 things. We're given this fact, and we're given this fact, okay? So if I tell you, hey, I run at this pace, and then I say, I'm going to run for this long, you should be able to identify the distance. Remember that distance is equal to rate times time. So here we're given, we don't know the distance, we're given a rate, 100 meters per minute. We're given a time of 30 seconds, aka half a minute. So I can find my distance just by doing the 100 meter, and you should put your units in here just to make sure everything cancels out. Let's write it like this. 100 meters, 1 minute. Multiply that by half a minute. Okay, so minutes and minutes cancels out. I'm going to end up getting a distance in meters. Distance equal to 50 meters. 100 times half. Okay? Now, I also know that it's an equilateral hexagon, so that means AB, this length is equal to this length. If Joey maintains his 100 meters per minute pace, what is Joey's speed in feet per second? Okay, so this is just a unit conversion problem. So we're going to convert 100 meters in 1 minute. We're going to first do a conversion factor to get it from meters per minute to, let's do meters per second. So we want to convert minutes to seconds, right? So 1 minute, 60 seconds. And then we want to do a conversion factor. This will take care of the minutes and get us meters per second, but we want to get feet per second. So we got to go from meters to feet. So 1 meter, or 0.3048 meters, is equal to 1 foot. Okay. Now the meters here will cancel. We end up with feet per second as our units. Now, how did I set this up? So let's backtrack. So to start, you want to start with your original units, okay? And you want to know what your desired units are. So we see that there's two differences. There's meters to feet, minutes to seconds. So I'm going to have two conversion factors, one to handle each of those differences, okay? And in each one, you write, so you just keep in mind, what am I going to do with each conversion factor? One of these is going to be to go from meters to feet. Let's just say m to feet, and this one's going to be to go from min to s, minutes to seconds. So to go from meters to feet, you're gonna you have this meters to feet kind of ratio, right? You know that 1 foot is equal to 0.3048 meters. How do I know whether to put 1 foot here or put 1 foot here or put 0.348 on the top or on the bottom? Always remember your desired unit goes opposite of where your original unit is. So your original, in the conversion factor, your original unit is always opposite where it is in the original fraction. So in the numerator of the original ratio, I have meters. That means in the denominator of the conversion factor, I'm going to have meters, 0.3048 meters. Now what this does is when I evaluate just this piece right here, meters will cancel out. And the numerator unit, which will be 1 foot, that'll remain, okay? And that's going to carry through to the end of the problem, to my answer. Okay, same thing. I have minutes in the denominator. I'm going to put minutes in the numerator. It's opposite of the original place in the original fraction. And then I just can remember that 60 seconds is the equivalent of 1 minute. So yeah, again, meters cancels out with meters. Minutes cancels out with minutes. Feet per second. And you can evaluate this just without the units, right? Now that you know you have the units right, 100 divided by 0.3048 times 1 over 60 is equal to, do it on my calculator because I'm not going to do that in my head. So 100 divided by 60 divided by 0.3048, 5.46. All right, that's it for that one. If the divider shown by AD is 20 yards in length, what is the area of the hexagon to the nearest square yard? Okay. Divider shown by AD is 20 yards in length. What is the area of the hexagon to the nearest square yard? So this is 20, right, from here to here. Now, what you can do is since this is an equilateral hexagon, you can just split it up, and each of these lines, these purple ones, they're all the same, okay? And I know that one of these purple lines is 20. That means that half of them is 10. Okay, and you can leverage that by saying, okay, an hexagon is really just an equilateral hexagon is really just 6 equilateral triangles put into this kind of like a pizza. And if you find the area of one of them, you have the area of all of them. You could just multiply that 1 by 6. Okay, so let's just say, let's focus in on one of these triangles. This one right here. So we know that 10, 10, 10. You might recall there was an earlier problem where I was solving for an equilateral triangle, or I was solving for an isosceles triangle, and I split it in half to identify the area. We're going to do the same thing here, okay? I'm going to split this in half, and I'm going to identify the area. Now, actually, Since I already showed you that method in an earlier problem, I'm not going to do that same method here. Rather, what I'm going to do is I'm still going to split it in half, but I'm going to do a slightly different way of solving it. So now we have our split in half triangle. Looks like that. This is 10. Now, this is going to be 5 because the original dimension is 10. Half that is just going to be 5. I actually know this angle. I know it's going to be 60 degrees because it's an equilateral triangle. This is going to be 30. This is going to be 90. So it's a 30, 60, 90 triangle. If you remember your 30, 60, 90 triangle ratios, the longest leg is really just going to be, it's the hypotenuse times square root of 3 over 2. So this is just going to be 10 square root of 3 over 2, which is 5 square root of 3. Okay, so now that I have that, I can do, I know my height. So height is equal to 5 square root of 3. Your base is equal to 10 of the triangle. That means that area is equal to half times 10 times 5 square root of 3. Okay? So it's going to be 25 square root of 3. Let's just, and since this, and the answers are not given in this form, or sorry, that's the area of one triangle. Now we're going to multiply that by 6. So 3 to the 0.5 times 25 times 6, 260. Okay, moving on. What is 72% of half? So whenever you're asked to find a percent of something else, you're going to take the decimal equivalent of that percent. So 72% is equal to that. We're going to move the decimal 2 places to the left, 0.72, right? And you're going to multiply the decimal equivalent by the number that the other number. So 0.72 times 0.5, which is half, is equal to, it should be 0.36. Now, you might be thinking which of these answer options is equal to 0.36. You could just plug all these into your calculator. You'll find that it's going to be answer option B. So just do 4 divided by 15, 9 divided by 25. You'll find that it's answer option B. Lily puts a stake into the ground. She attaches a leash to the stake and her bulldog's collar. The dog could reach 5 yards from the stake in any direction. Using 3.14 for pi, what is the approximate area of the lawn in square feet that the dog could reach from the stake? Okay, so what's really happening here? So there's a stake in the ground, and there's a leash attached to it, and the leash is 5 yards. And on the other side of the leash is a dog. Dog. Okay, and the dog could reach 5 yards in any direction. So if I was to draw a circle, this would be 5 yards radius. Think of it that way. So we're basically asked, using this information, what's the total area of the lawn in square feet that the dog could reach? So the area, first of all, your radius is 5 yards, which is equal to 15 feet, right? Because 3 feet in a yard. So if I just take my area formula, pi r squared, I do 3.14 times 15 squared, I end up with my answer of 3.14, 706.5. It's D. Right, simple enough. Two squares have a side length ratio of this. The smaller square has a side length of x. What is the difference in square and area between the larger square and the smaller square in square units? So let's just visualize it to make it easier for us. So small square, large square, okay? So smaller square has a side length of x. Now we know that the ratio is 1 to 3, so that means this is going to be 3x, right? What is the difference in area between the larger square and the smaller square? So area of small is going to be equal to x squared. Area of large is equal to 3x all squared. It's not 3x squared. It's 3x all squared, okay? Because 3x is just your side length. You have to square your entire side length. This is going to be 9x squared. Okay, so difference, 9x squared minus x squared is equal to 9 minus 1 times x squared, 8x squared. Okay, remember to combine like terms, but to do it correctly. If 4 to the x equals 900, then which of the following must be true? There's two ways to do this. One is to use logarithms. So you could do, remember to b to the x equals y. Sorry, hold on one second. B to the x equals y. This, if you want to solve that, you can do log of y divided by log of b, or log by equals x. Okay. you can do either of these on your calculator. In this case, you'd get 4 to the x equals 900. Log of 900 divided by log of 4 is equals to log to the 4 900. And this gives you 900 log divided by 4 log 4.9. That means this is your answer. Or you could just do, okay, 4 to the 1 is equal to 4, 4 to the 2 is equal to 16, 4 to the 3 is equal to 64, 4 to the 4 is equal to 256, 4 to the 5 is equal to 1024, I believe. So between here and here is where I see I pass 900. That means my answer has to be between 4 and 5. That's the fastest way to do it. Lines M and V lie in the standard xy coordinate plane. An equation for line M is this. The slope of line V is 0.01 greater than the slope of line M. What is the slope of line V? Okay, so slope of slope of line M is this, okay? Is this 0.35. M of M is equal to, so I'll call it this way. Slope of M is equal to 0.35. Slope of V is equal to slope of M plus 0.01. 0.01 greater than the slope of line M. That's exactly what I'm saying right here. So just plug in this for this, 0.35 plus 0.01 equal to, and if you want to make it very clear, 0.35 plus 0.01, just add across like this, end up with that, okay? What are the quadrants of the standard coordinate plane that the equation passes through, okay? So let's, the way I would do this, I like to convert to y equals mx plus b form. So, or you can, there's two ways to do it. I'll just show you both. So you could first say, okay, I'm going to find the x-intercept. So make x equal to 0. I end up with negative 6y is equal to 4, which gives me negative 6, y equals 2 over 3. X equals 0. Okay, so when x is equal to 0, which means you're along the x-axis, or sorry, you're along the y-axis, this is the y-intercept, y is equal to 2 over 3. Okay, let's just say this is 2 over 3. Okay, now make y equal to 0 to find your x-intercept. Negative 3x is equal to 4. That means I get x equals, or sorry, hold on. This should be negative 2 over 3 because it's 4 divided by negative 6. X equals negative 4 over 3. Okay? Negative 4 over 3. Somewhere over here. So your answer is going to be quadrants 2, 3, and 4. You could also do y equals mx plus b, so you'd move the 3x to the other side, divide everything by negative 6, and you'd get an equation. You could graph the y-intercept and the slope, and you'd get the same answer. A rectangular prism is 21 feet tall and has a square base with a width of 8 feet. What is 1/4 of the volume of the figure in cubic feet? Okay, so let's find the volume of the figure in cubic feet. Volume is equal to length times width times height for a rectangular prism. 21 feet tall has a square base. Square base, what does that mean? So this, at the bottom right here, you have a square. So 8, 8, 8. That means, yeah, I know that this, my width is 8, my length is also 8. Okay? And my height is 21. So V equals 8 times 21. 64 times 21, 1344. Now the problem's asking for what is 1/4 of the volume of the figure in cubic feet? 1/4 V is equal to 1/4 times 1344, 336. A car accelerated from 45 feet per second to 130 feet per second in exactly 5 seconds. Assuming the acceleration was constant, what was the car's acceleration in feet per second from this to this? Okay. So you treat it just like a slope problem. So at T1, you're doing, so you treat it like your x values are time, call it seconds. Your y values are velocity, feet per second, and your m is going to be acceleration. It's going to be in units of acceleration, feet per second squared. Okay. And I'll show you how this all lines up in y equals mx plus b form. So first, let's do the y equals mx plus b form. I'll just show you. So you have your unit y equals mx plus b, right? So you have your original speed, 45 feet per second, right? At t equals 0 or at x equals 0. So that's reflected if I was to put this in a table. 1, 2, 3, 4, 5. So let's start with 0. 0, 1, 2, 3, 4, 5, right? So at x equals 0, at the very beginning of this, we're going 45 feet per second. All right. Now, after 1 second, well, that's what we're trying to find, right? But I'll just show you the units, how these work out. So you have feet per second is equals to feet per second times feet. Oh, hold on, I have to write it like this. I'm going to write it as fractions instead. It's easier to break down units that way. Feet per second is equal to feet per second squared times seconds, right? Because x is time in seconds, plus feet per second. You see that they're all, this cancels out. I end up getting feet per second is equal to feet per second plus feet per second. The units all cancel. They all add up to just feet per second, right? That means everything lines up. Okay, so now knowing this, I can use the slope formula where, for example, if you remember, m is equal to y2 minus y1 divided by x2 minus x1. And I can do, and I can find this is going to give me m in what? Feet per second squared, which is feet per second, and that's going to give me my answer. So at t equals 5, I know that I'm going 130 feet per second versus t0. And then it's going to be t equals 5 minus t equals 0. So what's 130 minus 45? That gives me 85 over 5. So I end up with the answer of 17. A pastry chef makes a profit. And so I guess the last thing I'll say, right? If you go ahead and plug into this problem, y equals 17x plus 45. If you plug this into this problem, you'll end up getting, it'll show you this is going to be 45 plus 17. And it's going to be that plus 17, then that plus 17, all the way up until 130. Okay, so you're increasing 17 feet per second every second. A pastry chef makes a profit of this from selling pea pastries. To maximize profit, how many pastries does the pastry chef need to sell? So to maximize profit, how many pastries does he need to sell? So we need to find essentially where do you reach the maximum value in that equation, in this equation right here. So let's just say y is equal to 280p minus 2p squared, right? This is my profit. Sorry, they make profit from selling pea pastries. Y profit. That's the unit of y is profit. P is pastries. Okay, so how do you find a maximum value in an equation? You could do a derivative, but that's calculus, so we're not going to make you do that. The other way is to identify if you remember what a quadratic equation looks like, and this one has a negative in front of the square term, so it's going to look something like this. Okay, if you remember, if you have two x-intercepts like this, then exactly halfway between them is going to be your maximum, or your maximum, right? So if you identify the x-intercepts, or essentially these points, and you go exactly halfway between them, that'll tell you where you have your maximum profit. And you'll know the p-value here, the pastries. So let's just make this equal to 0 then. Find the x-intercept, and then go from there. So 0 is equal to 2, so negative 2p squared plus plus 280p is equal to 0. So divide everything by 2. Negative p squared plus 140p is equal to 0. Let's get rid of this negative. So p squared, and by multiplying everything by negative 1, p squared minus 140p is equal to 0. And then just factor. P times p minus 140 equals 0. That means p is equal to 0 or p is equal to 140. That means that when p is equal to 70, you're going to have your maximum. That's your answer. And you can go ahead and graph it to make sure. If this method doesn't make sense, just go ahead and graph this equation. This equation. Y equals 280x minus 2x squared, and you'll find these two x-intercepts, and you'll find the maximum value, which maybe you actually can identify with a graphing calculator. I'm forgetting. But you can actually identify that analytically by doing the work I just showed you. What is the product of these complex numbers? Just do the FOIL method. So first, outer, inner, last. So let's do the first. Negative 5i times 5i equals, so combine 5 times 5 is 25. I times I, it's negative 5 times 5, it's negative 25. And then I times I is going to be I squared. This gives you negative 25 times negative 1, which is going to be 25. Okay. Outer, negative 5 times 3. 5i times 3 is equal to negative 15i. Inner is going to be 5i times 3. 5i times 3 is equal to 15i. And then last, 3 times 3 is 9. Okay. Now let's add up 25 in all of these. So 25 minus 15i plus 15i plus 9. These two cancel, you end up getting 25 plus 9, which is 34. What is the difference between the mean and the median of this set? Let's find the mean. It's going to be equal to the sum divided by the number of numbers. So if you find the sum, just 20 minus 3 plus 9 plus 14 minus 5. Divide by 5. You end up getting 7. Median, if you just order the numbers from least to greatest, and then find the value in the middle, that's your median. Okay, so 7 and 9, difference is 2. A cube X has a surface area of 768 square centimeters. Cube Y has half the surface area that cube X has. So what is the sum of the edge lengths of cube Y in centimeters? Okay. Surface area of this. So let's first identify what the surface area and essentially how it relates to edge lengths, okay? For cube Y. So we need to actually start with cube X and find the edge lengths and then relate that over to cube Y. All right, so what do you think the formula of surface area of a cube is going to be? Let's just take one face really quick and start with there, okay? So the area of a face is just going to be equal to, if I call this length L squared, right? Now, a cube has how many faces? Well, if you draw out the part you can't see, you'll see that there are 3 faces you can see, right? I mean, if I just look right here, 1, 2, 3, right? And then the ones that I can't see, there's 1, 2, 3, right? On the back side and the bottom and the left. 3 plus 3 is 6, so you end up with a total of 6 faces. So let's call it this. Surface area is equal to 6 times area of the face, which is equal to 6L squared. Okay, that's your surface area formula. Now, surface area of cube X is equal to 768 centimeters squared. That's equal to 6L length of X squared. So if I was to solve this, I can solve for length. I don't know if I need that yet, but just something we'll keep in our back pocket, okay? It says surface area of Y is equal to half surface area of X. Half times surface area of X. That's going to be half times 768. And what's 768? divided by that, 384. Now I can use my 6L squared. So 384 equals 6L squared. I can solve for L, and then I can add up all the edge lengths of L by counting edges, which I'll show you how to do in a second, and get the answer, okay? Divide by 6. 64 equals L squared. 8 equals L, okay? Now I know that each edge is going to be 8 units long, 8 centimeters. How do I find the number of edges? Well, I can just draw all of them like I did earlier and then count. So if I look at the bottom square, I have 4. Top square, I have 4. That leaves me with 1, 2, 3, 4. So 4 plus 4 plus 4 is 12. 12 edges in a cube. 8 times 12 is equal to 96. What is the volume of cube y to the nearest cubic centimeter? Now, it's good that we found the edge length of y, right? Ly is equal to, let's make this clear, it's Ly, not Lx, it's Ly. Ly is equal to 8. Now, the volume of a cube is just going to be L to the third. It's really the same thing as like we did a rectangular prism earlier. It's length times width times height. But since length is equal to width is equal to height, because it's a cube, all the edge lengths are the same, you could just write it as this. Okay? So Ly to the third is going to give me Vy. That's going to give me 8 to the third, which is going to be 512, I believe. Let's just double check that. And that's the answer. Okay, a third cube, cube z, has twice the surface area of cube x. What is the ratio of cube z's edge lengths to cube y's edge lengths? Okay, so cube z has twice the surface area of cube x. So remember, from here to here, it was half, right? That means from here to here, it was times 2 as far as the surface area. Now, if I go again times 2 to cube z, what did I do to my edge length? So let's just think of what we did to our edge lengths and apply that again. So from y to x, our volume times 2, surface area went times 2. But what did our edge lengths do? So I want to evaluate for my Lx here to get my edge length of x. So 768 divided by 6 is 128. So 128 is equal to Lx squared. 128 to the half is equal to, so Lx is equal to whatever 128 to the half is, 11.33, 11.31. Okay, so this versus this. Now, if you're wondering, okay, what's the exact ratio? If you divide 11.3 by 8, you end up with 1.14, which is square root of 2. Okay, so I notice, I'll write this way. So from x to y to z, let's make a table. So surface area, length, x, y, z. So from x to y, our surface area doubled. From y to z, it also doubled. My length of x, my edge length from x to y increased by square root of 2. So I'll just show you. I'll write them out. So it was 8. So Lx was, or sorry, hold on. Which one was the biggest? Oh, I think I have this. I need to correct these labels. So your smallest is y, x is your middle one, and z is your largest, okay? So my Lx was 11.3. Ly is 8, and this is the question, right? So what you'll notice is this is actually an increase by 1.41, aka square root of 2, right? So if I do the same thing again, if I increase my surface area by the same ratio, I'm going to do the same thing again, times 1.414 times square root of 2, okay? That's the ratio of the edge lengths from x to z. Now, the question is not x to z, it's z, it's from z to y. So we're comparing z to y. It's really going to be, so it's going to be, z is going to have square root of 2 times square root of 2, which is 2. The ratio is going to be 2 to 1, right? Because z is going to be larger than y. You can't, if you're between b and c, you can't say 1 to 2 because z is bigger than y. We're looking for z to y. This is z to y. This is y to z because y is smaller than z. So your answer is going to be B. Given f of x equals this, and h of x equals x squared plus x, which of the following is an expression for f of h of x? So f of h of x is going to be where we just plug h of x into the x value of f. Okay, so 3 times something minus 2 is equal to 3 times x squared plus x minus 2. 3x squared, we're going to distribute that, plus 3x minus 2. Is answer option A. Okay. An adventurer will go from a city to a village by one of 5 roads, from the village to a jungle temple by walking on one of 3 paths, and then from the temple entrance to the treasure room by going through one of 6 doors. How many routes are possible for the adventurer to go from the city to the village to the temple to the treasure room? Okay, so think of it this way. City, village, 1, 2, 3, 4, 5. And then village to a jungle, 1, 2, 3 paths. Jungle, and then from jungle temple to the treasure room by going through one of 6 doors. 1, 2, 3, 4, 5, 6 door. Okay. Really, this is just a combination problem, so you're going to do 5 times 3 times 6. That should give you 90. Okay. Negative 5x to the third all to the negative 2 is equivalent to what? Okay, so let's first deal with this negative 2 exponent. If you remember, any base that's raised to a negative exponent is really the same thing as putting a 1 over that same base raised to a positive version of that exponent, okay? Or flipping the sign of the exponent effectively. So let's apply the same principle here. So we're going to essentially write this as 1 over negative 5x to the third all to the second, okay? Really the numerator is also to the second, but since it's 1, it doesn't matter in this case, okay? Now we can evaluate what's on the denominator. So 1 over, we can distribute the exponent to each of these terms. 1 over negative 5 to the second, x to the third to the second. Now here we have exponent to an exponent. If you remember, a to the b to the c, for example, is equal to a to the b times c. Exponent to the exponent, you multiply the exponents. So we're going to get 1 over 10 times x to the 6th. Not x to the 5th, x to the 6th. Or sorry, not 10. It's going to be 5 squared. So 25. 25x to the 6th. C. In the figure below, the area of the larger square is 32 square inches and the area of the smaller square is 8 square inches. What is the dimension x in inches? Okay, so if I call this dimension A, and I call this A, this B. So I know that A squared is equal to 32 and B squared is equal to 8. That means A is equal to square root of 32, which is equal to square root of 16 times square root of 2, which is equal to 4 square root of 2. Whereas B is going to be equal to square root of 8, which is equal to square root of 4 times square root of 2, which is equal to 2 square root of 2, okay? So I have B and I have A. I know that, and I also know, so if this whole thing is A, and this is B, that A minus B, I can actually evaluate that. That's going to be 4 square root of 2 minus 2 square root of 2. It's equal to just 2 square root of 2. You can do all of that in decimal form too. If I confuse you with the radicals here, you can just evaluate the whole problem in decimals, and you'll still arrive at this answer in a decimal equivalent form. Okay, so again, just leveraging the information that you have and using it. Selena has taken 4 of the 7 equally weighted tests in her literature class this semester and has an average score of this. How many points does she need to earn on the upcoming 5th test to bring her average up to exactly this? So if you remember, we had an average problem very similar to this earlier in the exam, and I showed you 2 methods. I'm going to use a method similar to the second method I showed you. I'm not going to show you both here because I already did earlier. You can go back to that problem if you want a breakdown of that. Okay, so let's just identify our knowns. Average that's desired is going to be 89. The number of tests is going to be 5. And the unknown is going to be the sum, right? Of what's the total sum of points, because we don't know what this last test is going to be, so we don't know the sum. So remember, this is the average formula is this right here. Average equals sum divided by number of numbers. So let's just plug it all in. 89 is my average. That's the desired average. Is equal to the sum divided by the number of tests, 5. So my sum of all my points of all my tests should equal what? 5. 89 times 5, which is 445 points. Okay. Now, if I have an average of 87.5 for the first 4, that means that the first 4 tests, you could just model them as 87.5 plus 87.5 plus 87.5 plus 87.5, which gives you 350. Okay, so what's the difference between these 2 points? That's essentially what I need to earn on that 5th test. So minus 445 is going to give me 95. That's the answer right there, okay? So you're just, again, you're playing around with that sum. I set everything to be an easy value for me, which meets the requirement of an average of 87.5, which means the sum is going to be whatever it was, 445, or sorry, 350. And then found the difference between that and my desired sum. That's all it is. The inequality here is equivalent to which of the following inequalities? All right, let's just distribute 4 to that and 5 to that. So 4x minus 12 is greater than 5x plus 10. Now let's subtract 4x on both sides. Negative 12 is greater than x plus 10. Subtract 10 on both sides. Negative 22 is greater than x. If I rewrite this, it's x is less than negative 22. So I could rewrite it as x is less than negative 22. Sorry. X is less than negative 22. It's just rewriting it left to right. Okay. A particular circle in the standard coordinate plane has a center of this and a radius of that. What is the equation of the circle? So if you remember the parent form of a circle equation, it's going to be x minus h squared plus y minus k squared is equal to r squared. Okay, where h comma k is your center point and r is your radius. Okay, so I know that r radius is equal to 10 squared is equal to 100 squared, 100, right? So these are out. Now all I have to identify is, do I need pluses or minuses? If my center point is 7 comma 1, I see that the parent form, if you remember it, you're going to have x minus 7, y minus k, right? Because this right here is 7 comma 1. X minus 7 squared plus y minus 1 squared is equal to 100. B is my answer. The coordinates of the endpoints of line segment AB in the standard coordinate plane are this. What is the y coordinate of the midpoint of AB? Okay. So how do you find midpoint of 2 points? Midpoint is really just a fancy way of saying average. So if I have 2 points, I'm finding the average x value, average y value, and that's what I get as my midpoint. So if I'm asked to find the average y coordinate, which is, forget the x's here. What's the average between 2 and 12? It's 7, right? You could do 2 plus 12 divided by 2, right? Remember, average formula is equal to sum divided by number of numbers. Sum will do that. We'll add them together. Number of numbers is 2. 14 over 2 is equal to 7. All right, we're getting to the last 10 to 15 problems. Given that A times this matrix is equal to this, for some real number A, what is X plus Y? Okay. So X plus Y, how do I actually do this? How do I identify what X and Y are? Well, I know that I have corresponding terms 4 and 6, which really aren't just 4 and 6. They're 4A and 6A, because this constant A multiplies over into all four of these, kind of like distributive property. And I notice I have one known value here. So I know that 2 corresponds to 15, which is, again, really 2A is 15. If 2A is equal to 15 per this, that means that if I divide by 2 on both sides, A is equal to 7.5, right? And I can use that A and say, okay, A times 4 is equal to X. So, and again, same thing with Y. A times 6 is equal to 7. Sorry, A times 6 is equal to Y. So let's do that. 4A is equal to X is equal to 4 times 7.5, and that's equal to, I believe, 30. And then 6A is equal to Y is equal to 6 times 7.5, and that's going to be equal to 45. X plus Y is then going to be 75. Okay, you're just adding these two together. X plus Y. All right, so remember, if you have a number outside of a matrix like this that's multiplied, you always remember you're multiplying it by not only the matrix, but by each term in the matrix. A watering can is 1/6 full of water. After 6 more cups of water are added, the container is 2/3 full. What is the volume of the watering can in cups? So we're finding the total volume of the watering can in cups, right? So what I want to do is I want to identify what proportion of the watering can is equal to 6 cups. And then I can extrapolate that to identify what would the entire proportion, what would the proportion of 1 be to the volume. So let's break that down. So first I want to identify, so starting condition is 1/6 full. Ending condition is 2/3 full. Between here and here, we know it's 6 cups. Okay. I want to identify what's the actual change in proportion here. So 2/3 minus 1/6 is the same thing as saying 4/6 minus 1/6. That's 3/6, which is equal to half. And this corresponds to what we added, which is 6 cups. Okay, so if I know half of the container is 6 cups, then that means the entire container is going to be 12 cups. Okay, let me visualize the problem in case that didn't make sense. So let's just do this. So you have a container, originally 1/6 full, and then we add stuff and it becomes 2/3 full. We don't know how much is here. We don't know what's up here, what's left. Actually, we do. We know that it's 1/3 is left, but we don't know the exact quantity of it. We don't know if it's a gallon or if it's a cup or 7 cups, whatever, right? All we know is we added 6 cups and we went from 1/6 to 2/3. So what was added here was half. And this is 2/3 of the entire cup, not 2/3 of something else. It's 2/3 of this purple cup, 1/6 of this purple cup. And if I know that this 6 cups corresponded to whatever the difference is in that ratio, 2/3 and 1/6, then that means that what I calculated as, half, which is the red. If half is 6 cups, that means 12 cups is going to be the full. If A to B is 1/3 and B to C is 2/3, what is the ratio of A to C? The easiest way to solve this is to make, just think of it as ratio. So A over B is equal to 1/3. B over C is equal to 2/3. That means A over C is going to be equal to A over B times B over C, because B's will cancel. Okay, so just do 1/3 times 2/3. You end up getting 2/9. 2 to 9 is A to C, and that's your answer. The cylinder has a height of 12 inches and a volume of 432 pi cubic inches. The formula for the cylinder is this. That's the volume formula. What is the diameter of the cylinder in inches? Okay, so let's take our knowns. Volume is equal to 432 pi Now, let me just plug the formula into that. So in 432 pi is equal to pi r squared height. Oh, sorry, we also know that height is 12. Okay, so the only unknown is radius, right? Let's just solve for that. So divide both sides by pi, they cancel out. 432 divided by 12, what is that? 432 divided by 12 is going to give me 36. 36 is equal to r squared. R is equal to 6, okay? We're asked for the diameter. It's just going to be double that. It's going to be 12. Okay. Which of the following is the solution for the inequality shown below? So what you're going to do is really treat it as a problem that has three sides. So we're going to just try to isolate x like we would do in any other inequality or equation, but we're going to do to all three sides of this. So for example, -2, we're going to do that everywhere to get rid of that. We do to all three sides. So -6 is less than -2x is less than 10. Divide everything by -2. We end up getting 3 is greater than x is greater than -5. Okay, when you divide by a negative number or multiply by a negative number in an inequality, you have to flip the directions of the signs. Now let's just write this in reverse. It's -5 is less than x is less than 3. -5 is less than x is less than -3, or less than +3. A circle in the standard coordinate plane has the equation this. Which xy coordinate pair is outside of the circle? All right, let's graph this. Make it visual, make it easy to understand. So this equation, if you remember, I showed you the parent form of a circle equation above. It was x minus h squared plus y minus k squared is equal to r squared, where h comma k is your center and r is your radius. Okay? So here, your radius squared is equal to 40. That means r is equal to square root of 40, which is going to be equal to some number, okay? Let's just identify the decimal equivalent to that. 6.32. Okay, so you're going to have a radius of 6.32. And then what's your center point? X minus h. So with this is x plus 5, it's going to be x minus -5. This gives you x plus 5 squared. That's why you see it written as x plus 5 when the parent form has a -5. So your center point is x equals -5, y equals 0. Okay? Just call that right there. Actually, I'll put it right here. Okay? Let's put it right here. Okay, so -5, comma 0. And if I was to draw the circle, again, with a radius of about 6, it would probably extend something like this. Okay, so it makes sense. It's going past the, if this distance right here is, if this distance right here is 5, it makes sense that the circle goes a little past that, right? Past the origin. Okay. So which coordinate pair is outside the circle? -5, comma 5? Well, I'd say that would be like right, no one's tough, it's right here. Let's just plot all of them where we think they are, and then let's go from there. So I think that one might be outside 1, comma 0. Well, if we know that we can go 6.32 in this direction, we should effectively think of it this way. We can go 6.32 in any direction from this, and we should still, and we'll be on the circle, or in it, on or in. I can go 6.32 in this direction, and I end up at 1.32, comma 0, right? Because -5 plus 6.32 gives me 1.32. So 1, comma 0 is going to be in the circle. That's 1, comma 0. -5, comma 5. I think that's in the circle. -9, comma 2. So, okay, -9 is going to be all the way. Actually, it's going to be only 4 away, right? So it's going to be up here somewhere. Oh, actually, sorry. -5, comma 5 is actually going to be up here. -5 from the origin, right? -5 and then up 5. Remember, we can go up to 6.32 in the vertical direction from the center of the circle. So Negative 5 comma 5 is going to be right here. That's also in the circle. That's also in the circle. Negative 7 up 4. Let's check where that one might end up. Negative 7 is going to be right here. And then up 4, you're going to end up right here. I think that's in the circle. Negative 8 comma 6. Okay, this one might be tough. Negative 8 and then up 6. So remember, we can go up 6.32 in this direction, but 6 straight in this direction might be a little too far. So I'm going to say that one's, if I had to guess, out of the circle. So if I had to guess, this is how I would do it. Now, how do I verify? So let's take this point and let's find the distance from, let's find this hypotenuse and see if it's greater than 6.32. Okay, how do we do that? Well, I know that this dimension, if you use distance formula between 2 points, you know that this dimension right here is going to be, and I'll do it in red. This dimension is going to be from negative 5 to negative 8 in the x direction, 3. This distance right here from 6 to 0 is going to be obviously 6. So do Pythagorean theorem, 3 squared plus 6 squared, do the square root, you end up getting 9 plus 36 to the 0.5 is going to be 6.7. Clearly that's going to be greater than 6.32, greater than the radius of the circle. That's outside the circle. So typical distance formula problem. You could, in theory, do distance formula for each of these points and solve it, but it would get a little difficult. A horse eats 5 bales of hay in 2 weeks. At this rate, how many bales of hay does the horse eat in 2 plus W weeks? Okay, so the ratio of bales to weeks is always going to be the same. 5 bales to weeks, right? So if I do, this always has to be the same. So it's, if I do, we're trying to find how many bales is it going to eat in 2 plus W weeks. So let's just call it X bales. We're going to solve for this. We're going to do 2 plus W weeks. So if I just do it in numbers, it's going to be 5 over 2 equals X plus 2 plus W. X over 2 plus W. Solve for X. So 2 plus W is equal to X. So this cancels out. X equals, I'm going to distribute 2 to 5, 5 over 2 to 2, and 5 over 2 to W. So 5 over 2 times 2 plus 5 over 2 times W gives me 2 to cancel. We end up with 5 plus 5 over 2W. Or you could write this as 5W over 2, right? That's it. That's how you do that one. As part of a probability experiment, Jenny is to answer 3 multiple choice questions. For each question, there are 4 possible answers, only one of which is correct. If Jenny randomly and independently answers each question, what is the probability that she will answer the 3 questions correctly? Okay, 3 multiple choice questions. 4 answers, each 1 correct, right? So you have probability of getting each one right is just 1 out of 4. So what's the probability of 3 Q's right? So this is, if you remember and versus or probability, this is going to be and probability. And probability is where you have multiple independent events and you're trying to find what's the probability of all of those independent events happening. So you'd multiply the probability of each event by all of the other probabilities of the other events. So probability of each event is going to be 1 over 4. You're just going to multiply that by itself 3 times. Effectively 1 over 4 to the 3rd, right? That gives you 1 over 64. Okay. Our room has a rectangular floor that is 5 by 8 meters. What is the area of the floor in square centimeters? So remember the unit conversions we did earlier. So we have, let's first remember 1 meter is equal to 100 centimeters. Okay, so I want to convert from, the easiest way to do this, first just think, okay, let's first convert 5 and 8 meters to centimeters. So 5 meters is going to equal 500 centimeters. 8 meters is equal 800 centimeters. multiply these two together to get area, right? It's rectangular. So we end up getting 800 times 500 is equal to, just do in your calculator for sure. We end up getting 4 with 5 zeros after it. Centimeters squared. Now, there's other ways to do it. You could do the unit conversion after you multiply. So you could do it like this. You could say, okay, 4 times 5 is equal to 40 meters squared. Sorry, 4 times 8, right? 40 meters squared. So I want to convert 40 meters squared by some conversion factor and get centimeters squared. Okay? What I could do is in denominator, I put meters. Numerator, I put centimeters. 1 meter is 100 centimeters. Then I square the whole thing, right? Because in order for the units to cancel, I need to have square. So in this case, the units will cancel because it's centimeters squared. This is going to be meters squared. It'll cancel with meters squared. It's 40 times 100 squared is equal to 40 times 10,000. And, sorry, is it 100 squared? What's 100 squared again? It's 10,000. Yes, this gives me the correct answer. 40 centimeters squared. Okay, you can do it that way too. I think it's honestly more confusing. So 2 methods, pick what you like. The 4th and 8th terms of an arithmetic sequence are 21 and 35 respectively. What is the 40th term of the sequence? Arithmetic sequence. So we're adding a value to the previous number every time. We're not multiplying, but we're adding or subtracting. Okay. So we're given 2 terms. Let's first, in order to find the 40th term, we're going to need to find the common difference and the 0 term. Okay. So let's first plug in what we know. We know A4 is equal to 21. That's equal to A1 plus n times, A1 plus n times D times n minus 1. Yeah, that's what it is. It's blanking there on the formula. It's very important that we remember that. All right, we need to find the common difference. We know that n in this case is going to be equal to 4. Let me actually write the parent form of this really quick for y'all. So we have it. An is equal to A1 plus D times n minus 1, okay? So A4 is going to be equal to 21. 21 is equal to A1 plus D times 20. And then for A8, we end up getting, this is not going to be 20. This is going to be common, this is going to be n minus 1. N in this case is 4 because it's the 4th term. So it's going to be 3 times D. Okay. And 35 is going to be equal to A1 plus D times 8 minus 1, 7. Okay. Now what I can do, if I want to find D, I can just subtract the first equation from the second, or the second equation from the first. I get negative 14 is equal to A1 minus A1 plus, and then 3D minus, it's 3D minus 70. Okay, so negative 14 is equal to negative 4D. Divide everything by negative 4, we end up getting D equals, it's negative 4, this is going to be 3.5. We're adding 3.5 every time. Now, knowing that, I can, the only other piece I need to find is A1 in order to use this formula to find A40. I can just plug in all my knowns. I know an AN, I know D, I know I have an N to go off of as well. So let's just take A4 and 21. So 21 is equal to A1 plus common difference of 3.5 times times 4 minus 1, which is 3. Okay, and let's just solve for A1. So first subtract 3.5 times 3. We end up getting A1 is equal to 21 minus 3.5 times 3, 10.5. All right, that's my first value. So now I know A1. I know D is equal to 3.5. Now let's find A40. A40 is equal to A1, 10.5, plus D, 3.5, times 39. And this is going to be equal to, just plug it all into the calculator, plus 3.5 times 39, 147. What is the period of the function? Note that the period of y equals 10x is pi. All right, best way to do this is just graph the function, okay? So what I'm going to do is put in the y equals mx, put in the xy coordinate plane. I'm going to pull up my graphing calculator, and I'm going to graph it. So give me 1 second while I plug this in. Okay, so y equals tan of 2x plus 4. Okay, so I'm going to just give you a screenshot of what I'm graphing as well, just so we can make this interactive. Okay, here we go. I don't even need to graph it myself. I'll just show you what I'm seeing on the graphing calculator. Okay. Here we go. So I have a point here and I have a point here. The distance between these two is going to be your period. Okay. Now, what you could literally do is try to count. This looks like it's about, negative 0.4. This one looks like it's about 1.2. Okay. If you add those together, you get about 1.6. That looks like, pi over 2. Period is pi over 2. Simple as that. Yeah, that's all it is. That's all it is. All right. I'm going to move on. The sum of two positive numbers is 200. The lesser number is 20 more than the square root of the greater number. What is the difference between the greater number and the lesser number? Okay, let's just take this piece by piece. Sum of two positive numbers is 200. So let's just say two positive numbers, x plus y, their sum is 200. The lesser number is 20 more than the square root of the greater number. Let's say x is the lesser number. The lesser number is 20 more than the square root of the greater number. What is the difference between the greater and lesser number? So what's y minus x? What's x minus y? That's what we're looking for, okay? There's a few different ways to solve this. One way is to just graph it, and since I'm lazy, I'm gonna do that. So yeah, let me just do that and I'll show you. So it says x plus y is equal to 200. You could plug that into so you could plug in the equation y equals 200 minus x, right? Yeah, you can do that. And you can solve this for y and do x minus 20 is equal to square root of y. You end up getting y equals, if you square both sides, x plus 20, x minus 20 squared. So x minus 20 to the second. I end up getting 2 points that I see. So I'll just graph what I see, show you guys. So you have a line that looks like that. Do a different color. A line looking like this. You have a quadratic looking like this. Okay. And remember, think of this in terms of x's and y's. Okay, so and do this in purple. So you're gonna get two solutions, right? Because you have a quadratic equation intersecting with a line, which makes sense. So the two solutions are this. One of them is going to be x equals 6.074, y is equal to 193.926. Other one is going to be x is equal to 32.926, y is equal to 167.074. Now you have two solutions, you have your conditions, just check which one matches both. Clearly, so this one, they both add up to 200. Right? Yeah, they both add up to 200. Now, do they both meet this condition as well? So let's just check. 6 is equal to 20 plus square root of this guy. Let me check right now really quick. So 193 square root. I guess it does, if you look at the negative square root, 20 minus that, yeah, you end up getting 6. And this one also. So I guess, yeah, here's where you end up. You end up with two solutions. And you basically need to check the answer options to see which of these actually is the one that's being talked about. So difference between the greater number and the lesser number. This one shows it being about 134. This one shows the difference between greater number and lesser number being about 186. That's not an answer option. So your answer, you have to go with this solution, okay? Even though this one does meet both these conditions, it's just not the one that the answer option is really asking you about. Ray LM bisects GLT. The measure of GLT is 16x degrees, and the measure of GLM is this. What is the measure of MLT? Okay, let's first plot this all out. So we have GLT. Let's call this G. Nope. Okay. So we have G, L, T, okay? And then we have ray LM that bisects it, which means it cuts it in half. The angle measure cuts it in half. Okay, so L, M, right? So whatever you had here as the angle, you're going to cut it in half and get this and this. Let's make this one blue. Okay. So this guy is 16x. This guy is 3x plus 10. And this also is going to be 3x plus 10. Now we're asked, what's the measure of MLT? Well, I just told you that it's going to be the same regardless. So what I could just do is say, okay, 16x is equal to 3x plus 10 plus 3x plus 10, right? You just add them together. Add this plus this has to equal that because it's a bisection, right? So let's solve. So 16x is equal to 6x plus 20 minus 6x minus 6x. 10x is equal to 20. X is equal to, just divide by 10, x equals to 2. Now, 2 is not your answer. You have to plug it back in here. So 3 times 2 plus 10 is equal to 16. So your answer is going to be B. Okay, that's the measure of MLT, which is also the measure of GLM. The graph of this is in the standard XY coordinate plane. Which of the following transformations, when applied to the graph of this, equals the result of that? Okay, so when applied to the graph of this, results in the graph of this. So what I would just do, plug it into your graphing calculator. Okay, so this is going to be, I'll just tell you now, it'll look like this. Absolute value of x is going to look like that. And that. Okay. And then y equals x plus 4 is just going to be the same thing, just over here. So what I'll do, copy, whoops, paste. It's going to be 4 units to the left. I'm pretty sure your graphing calculator should be able to do absolute value graphing. Now, if it's not, how do you know this? Well, there's a difference between if I said y equals absolute value of x plus 4 versus y equals absolute value of x plus 4. This one, whenever you apply the plus or minus transformation to the x itself or within parentheses or within an absolute value, it's going to go left or right. And if you see positive, that means it's going left. If you see the plus or minus 4 being added or subtracted outside of the parentheses or outside of the absolute value brackets, that means you're going up or down. Positive is up, down is negative. In this case, clearly it's inside the parentheses, so we're going to go translation to the right, or to the left 4 units. Okay, and you can graph it if it's possible on your graphing calculator, which I think it should be. You can use the abs function, if I remember correctly. So you do abs x plus 4. All right, hopefully this was helpful. If you have any questions, let us know in the comments down below, or leave a message on the website. We have more practice exams like this on the website for free that you can access. Just create an account. It takes like a minute or two. And hopefully this was helpful. Like I said, we also have courses if you want to see more problems like these, repetitive problems for each problem type, check out our website for courses that teach you the skills if you need that background. Not every student will, but it's something that can be helpful, and we've seen it help students in the past. So best of luck on your exams, and hopefully, like I said, this was something that was of assistance.